And we have resistances which we can probably call as R1 na, or you could have another one na? This is your R sub 2. Now our resistances, of course, no, there is a voltage here which we can call as the supply voltage. Now we will realize that in each of these in each of this wire, now there's going to be a current here that will be called I1 and I sub 2 that will flow across here. Now from the source of our battery, there's going to be another current there. Now we can call the current as I total. This is the current that eventually comes from the battery, no? I total. Now the current that will go down to resistance 1, we can call it I1. And then we can have here another current that goes to R2 as I2. No? Now you'll notice that all these currents will split up. No? So from the total current I coming from the battery, it will simply split up na, into 3 different directions. No? So what they discovered is that this total current I sub T, no, is actually equivalent to the sum of the individual currents, no, that passes our circuits. If you add I1 and I sub 2, no, it's equals to the total current coming from the battery. But how do you get the total current? Of course, you have to find out, no, the total resistance first. No? Now, if there are more resistances connected, then you can simply add more currents in the equation. No? So again, no, parallel connection is very common, no? Whenever we consider now the connections of the wirings that are in our home. No? Now, what they discovered, as the current I1 passes through R1, there's going to be a voltage that will now occur across R1. No? We call it as a voltage drop. No? Now, this voltage, we can probably consider it no, in terms of our total voltage. No? So total voltage is the one on this end, no, on the battery. But there's going to be another voltage V1 that will result whenever I1 passes through resistance 1. No? And there will be another voltage V sub 2 no? that will also result whenever current I1 passes through R2. Now, the relationship of the voltage 1 that results and the voltage 2 that results is actually equivalent no, to the sum of these individual voltages. No? When you add them together, it's equals to the supply voltage. Or, sorry, it is not added together, but the parallel principle is these voltages are all the same. No? Now, we see this practical illustration or this practical example whenever we connect our appliances in our house. All of our appliances in our house should be of the same voltage. No? Ang atong TV, your TV is 220 volts, your electric fan is 220 volts, your flat iron is 220 volts, your aircon, your ref, and any other equipment or appliance that you connect in the outlet, they should all be 220 volts. None of them should be less or greater than 220. Huh? So again, that's one thing we notice with parallel connection. So the currents are added together. However, the voltages are noticed to be all the same. No? Now, what about the determination of the total resistance? No? Now, the total resistance, similar to your capacitance, no? So we get the reciprocal So R total is equivalent to the reciprocal of the individual resistances. No? Okay, so this is how we get the resistances. So these are the three principles that basically govern the series
sir.
or the parallel connected resistances. No? So kung there are a lot more devices that are attached there, then you can simply connect them. No? Okay? So
Okay.
again, this is our parallel connected resistances. No? Now, for our illustration, for example, let us find now if for example R1 if our R1 is given, for example R1 to be equal to 10 ohms and R2 is equal to 20 ohms, no? What will be our total resistance, no? Okay? So 110 plus 120 na. Ilan ang total resistance natin, Jason? And then get the reciprocal.
110, 120, sir, no?
Oh, yes.
Plus
6 point pila na?
0.15.
No. Ma-reciprocal ka pa na.
Ay, reciprocal.
Di ba? That's 1 over our total is 1/10 plus. No? So our solution, no? So if we want to find the solution, so let's say find A, no? Our
Hello,
total, let's say B, we will find the total current, no? I total. And then letter C, no? We will look for I2.
6.66, sir.
Okay, so pila na?
6.66.
6.56, no? That's in ohms, no? So solution. So we get the reciprocal. So we will have no our equation nga 110 plus 120. Then the sum is we get the reciprocal of the sum. No? Now this is the answer for letter A. No? What about for letter B? No? How do we get the total current?
Add ng current, sir.
So B is I total is, how do we get the I total? I total should be V total over R total. No? So VT divided by RT. No? So
Our
VT
total.
is, wala na sang total voltage, di ba?
Why, sir?
Provide kita isang total voltage. Total voltage, for example, is 12 volts. No? So that's 12 volts divided by 6 point. That's 12 volts divided by 6.56. Okay.
Wala.
So pila na?
Sir, 12 times 8. Ay, 12.
My total
12
is
times 8. Sir, 6.66, sir. 1.8.
6 point
66, hindi 56.
66. Or 67, na gano'n na? Round off
No,
na.
sir. 67.
Okay, dayon pila ang I total? Divide please. 18. Hindi 18. 1 pila? 1.8? Oh. Okay, pila na? How much? So that's around 1.79 or 1.8 no? Amperes. Okay, so that's our first current. How about I2? No? Ano tawag ko sa I sub 2? I sub 2 is equal to, no? Peter, ara ka na?
Yes, sir.
Okay, I sub 2 is therefore equivalent to 12 volts man gyapon, no? E parehas na ang iyang voltage. Divide by the resistance of R2 na 20. Okay, that gives you, no?
0.6.
Divide by 20. So that's
0.6, sir.
0.6, no? 0.6 amperes, no? Okay? So ang total current was simply split, no? Ang isa 0.6, so kung i-minus mo na sa 1.8, another current I1 will be around 1.2. 1.2 plus 0.6 will be 1.8 all in all. Kaya ang current natin is simply added together. For letter D, we will find the power. So power is simply equivalent to V total times I total, no? So the total voltage is 12 volts. So that's 12 volts times total current of 1.8, no? So this is the power of the circuit. So 12 times 1.8, no? So you have 21.6, no?
0.6.
21.6 watts. Okay, so no? So this is the values of our, no? Of our parallel connected resistance, no? Okay, so